Hello everyone, welcome back again to another video tutorial from the AP3X Institute of Mathematics Education. My name is Akin, your math instructor, and in today's video we are going to be looking at the part 2 to our series of transformation videos. That is specifically we're going to be talking about rotation. Of course, in part 1 of that previous upload we had looked at the aspects, the fundamental aspects of rotation. That is, of course, what is a rotation, the direction of a rotation, the angle of a rotation. We also dived on into looking into the metric, the rotation metric, how to find the rotation metric and how to use matrices to map an object onto its image. So you definitely want to take the time out and to review that video before coming into this one, because of course in this particular upload we're going to be diving on into a little bit more in-depth information in regards to rotation. That is in fact how to find the center of rotation, how to use the rotation metric equation, and how to go on the graph and apply these concepts then. Alright, so this video is a little bit more in depth, particularly though I provide contents that are related to assisting Caribbean students that are doing CSEC exams, SEA, CSEC, EDXL exams. So I'm not sure the depth at which you're doing this topic, but of course I have to provide contents that spread wide and far in my audience here. So of course, if this video is suitable for you and you find it valuable, do not forget to subscribe to the channel where I post uploads weekly and daily sometimes. And of course, before you go, leave a like, leave some positive questions and comments down below, and of course do not forget to share this out to your math community. Alright, so for my CSEC students, I'm not sure, I've never really seen this level of question, but you never can tell. CSEC tends to come with some curveball questions, so let us adequately prepare ourselves for the possibility of these types of questions. All right, and for the other persons that are here that are watching this tutorial, I do hope that at the end of the video you have achieved your objective of understanding a little bit more about the topic of rotation. So without further ado, let's jump right into today's lesson. Now, of course, in this video, as I said, we're going to be diving on into more important information about rotation. And so specifically, we're going to be starting off this lesson with talking about the center of rotation. Of course, now we said that the center of rotation is the point at which the object is rotated from its current position to its new location. And in part 1, we discussed that the rotation is in fact most times always at the origin. But then what happens if the rotation point moves away from the origin? How does that help us? Now there's a couple of ways in which you're going to find tutorial instructors teach you how to find the center of rotation. Sometimes, given the question, you may be given a metric equation, as you're seeing here on screen, that you can use to find the center of rotation. You can also actually use construction lines, that is bisecting a line to find the center of rotation. And you can actually go ahead then and use various other methods such as translation to find the center of rotation. Now, the first one that I want to show you here is in fact how to use this very equation here on screen. This is called the center of rotation metric equation, or the mapping of the center of rotation onto itself. And so when the center when the origin is not the center of rotation, then what you find here is that the rotation is actually equivalent to a rotation about the origin combined with a translation. And now the rotation, whenever that happens, then you're going to find that the rotation is represented by the equation here on screen, ABCD multiplied by AB plus PQ is equal to, this should have been A prime B prime, pardon me, this should have been A prime B prime. So the ABCD represents the rotation metric for the object, for the angle. Okay, so this could be the metric for a 90-degree turn anticlockwise. It could be 180 degrees anticlockwise. It could be 270 degrees anticlockwise. That most likely will be provided to you. Now this A and B here represents the object point, the object that you're rotating. And so of course, because the center of rotation is not at the origin, then basically it's combined with a translation, which is represented by the metric PQ. And so by doing all of that, then, and doing this equation, then you're going to find here that it maps onto the object here, A prime, B prime. Now, bear in mind that if the center of rotation moves away from the origin, in my understanding, it's seen as if the center of rotation has been translated. So then we're going to change this from being the object point. We're going to change this from being the object point. Just a second here, guys. I think I might have shifted my page. Okay. I think I may have. Okay, gotcha. Here we go. So then basically then what this means for us then is that the object, the object that is now in focus here is actually the center of rotation, because that's the point that has moved away from the origin. That's the point that we're looking for. Now we know that it has been translated, but what is being provided here is that it has been, we have been provided with the vector that translated the center of rotation, but we are not provided with the center of rotation. That's what we're looking for. So we're now going to change AB then to the center of rotation. That's going to be our point, because now we're no longer focusing on the object and the image. We're now focusing on where is the new center of rotation, and we know it has been translated by a particular vector, which most likely will be provided to you. And so the image point then is going to be the new image of the center of rotation. Now if this was a different situation where we wanted to find where the object was, where the object would be going, then AB would represent the object point. Now here it represents now the center of rotation. Now this is all going to make sense when I look through this question here. And this is an applied question. You're going to find that something that you guys should actually know how to do pops up in this question. All right. And if you see this question on your exam, here is how you approach it. Now here it says that triangle LMN has coordinates L 21, M 52, and N 35, undergoes a rotation at the point AB and was translated by -3, 5 using the metric 0, -1, 1, 0. You're to calculate the coordinates of the center of rotation. Now you could go on the graph, right? You could go on the graph. You could plot the point 21, plot the point 52, plot the point 35, and then once you go there, then you can therefore multiply these object points here by 0, -1, 1, 0. Then you can plot the new points. Then you can go through the whole process of doing a construction. That takes a little time, and most likely then how this -3 and 5 play a role. And here's where you have to use the rotation metric equation mapping. So here what we do is that we take, say here, the metric 0, -1, 1, 0, and we're going to multiply it by, we're not going to use an object point because we're looking for where the rotation point is. The rotation point becomes our object point. So now we're looking for AB. And we know that because it moves away from the origin, we know that it combines with a translation that is in fact minus 3 and 5. And so therefore, by working this equation out, it's going to provide us with the position of the new center of rotation. So let's go ahead then and complete this equation. Now we're going to go row by column here, and we know that 0 multiplied by A is in fact 0, and negative 1 multiplied by B gives us, say here, negative B. And then of course we go to the bottom here, row by column. 1 times A is in fact A, and 0 times B gives us, say here, 0. That is in a matrix, and that then will be added to negative 3, 5. And then that's going to give us the position of A prime, B prime, which represents our location of the center of rotation. Let's go ahead then, and we're going to go ahead and say 0 minus B is negative B, and A plus 0 is in fact A, and that's going to be added to, say here, negative 3, 5, and that's equal to A prime, B prime. Alright, now once you've gone through that process, I'm just going to erase up top here because we finished with that part here. Okay, now we end up with a matrices that we have to add. So we're going to add negative B to negative 3, and we're going to end up with negative B minus 3, and we're going to equate the matrix to, say here, A prime, B prime. So we're going to call this A here, and then we're going to go down at the bottom here. I'm going to say A plus 5, that is A plus 5, and that's going to be equal to, say here, B. So now we end up with what is known here as a pair of simultaneous equations. Alright, and then so far what we're going to be doing is putting it in its normal form. So now we're going to bring this A over here. We're going to have negative A transposed to this side, and then we have minus B here. So we bring this A all the way in front of the B. We get minus A. The minus B comes after, and then we're going to transpose the 3 here because we want it in a normal simultaneous equation format. And then what we have next is A at the front here, and then we're going to bring this here. We're going to end up with minus B, and then that's going to be equal to, say here, negative 5 because we transpose this to this side. Now these two variables in the center, they already have the same coefficient. So this is of the assumption that you guys already know how to solve simultaneous equations. So here, because these two signs are the same, we're going to subtract to eliminate. So we're going to subtract top equation, we're going to subtract the bottom equation from the top here and here. So minus A gives us minus 2A, and of course the aim was to delete these. Minus B minus B is 0, and then this works out that 3 take away negative 5 is in fact 3 plus 5, which is 8. And so therefore then we end up then with negative 2A divided by negative 2 is equal to 8 divided by negative 2. It works out that the A is equal to negative 4. That means the x coordinate of our center of rotation is minus 4. Now we're going to go ahead then and we're going to sub negative 4 in, of course, equation 1 or 2. I'm going to just use equation 2 here. So I'm going to put minus 4 where A is. So that's minus 4, say here, plus 5, that's equal to B. And then of course then minus 4 plus 5 is 1, and 1 is equal to B. Therefore then our center of rotation is, our new center of rotation that is not at the origin, is located at, say here, minus 4, 1. Alright, so that's the little bit here. Let us do a quick little overview of what just went on moments ago. And it's a tricky little question. As I said, this may not be for my CSEC students. You may or may not see this type of question on your exam paper, but bear in mind that if it is that you end up with a situation like this where you're looking for the new center of rotation, provided that you are given the translation and the metric for the rotation. Then you can use this formula, say here AB CD multiplied by point A, point B, which can either be your object point or it can be the center of rotation, the unknown center of rotation. You're gonna then add that to the vector that translated the center of rotation, and that would provide you with, say here, the image of the center of rotation. Tricky little bit of question there, but I do hope that you got a little bit of clarity on that. All right, so hopefully if you've seen that question, then you're good to go. All right, now I do not have the digital tools here. I'm going to try my very best here, but I do not have the digital tools here to show you the bisection method, the construction method. So another method in which you could use to find the center of rotation is using what is known as the bisection construction lines. And so how this is done is by, well, in fact, what I'm going to do is that I'm not going to be discussing this section here as yet. I'm going to be waiting until I go on the graph, and then I'm going to show you what I'm talking about. Hopefully, I'm going to guide you verbally as best as I can so you guys can follow my instructions. If you're on graph, then you can try this, but you're definitely going to need a protractor and a pencil and possibly a, yes, you're going to definitely need a ruler. So I'm going to walk you through this in a moment. All right. Now, it says here that if the center of rotation is at the origin, then you don't have to do the whole construction. Once it is automatically at the origin, then all you have to do then is just connect the two corresponding points and it will automatically fall in the center. But once the center of rotation moves away from the origin, then you have to use then what we say construction bisection lines. All right, and there's in fact a cheeky little method. I recently discovered this, and oh, so easy it was to find the center of rotation even without the metric equation or construction. So hopefully in this video we'll be able to get into that. All right, now here we're looking at rotating an object when the center of rotation is not at the origin. Rotating an object from the origin uses a simple rule of interchanging ordinate values and changing points as discussed earlier in part 1. So in part 1 here we discussed that one of the easiest way to rotate an object is to actually be very aware of the changes. Now let's recap those changes from part 1. We said that in a 90 degrees rotation, you find then that if you have a random point xy, then what's going to happen is that it's going to flip, it's going to interchange, and the y value is going to change. That's what we went on with. All right, and then of course in 180 degrees rotation, we also said that if we have a random point, say xy, then what usually happens then is that it becomes negative x, negative y. The only thing that occurs here is a change in the signs. And we also said that if we have an object that is being rotated through 270 degrees, then you're going to find here that if we have a random point, say here, then what happens then is that it goes through an interchange process, but this time as opposed to the y changing, then it's the x that changes. And bear in mind that this rule is for an anti-clockwise rotation about the origin. Now, it's going to be the same even if the object point, even if the center of rotation is not at the origin, it's going to be the same rule, except because the center of rotation has been translated to a new location, that is automatically going to change the coordinates of the object. Now, to understand this better, we're going to have to go on the graph. And let us continue reading here. It says that when the center of rotation is not at the origin, then we have to create what is called a new x and y axis with this point. And then this new x and y axis that we create around this point will now be acting as our origin, where we are therefore going to have to create new coordinates for our object. Now I know that at this point, guys, you might be seeing that this is a little confusing, but I'm about to take you on the graph and walk you through this very simple process. I promise you, after this explanation, you are going to be using this method more often than not to find the center of rotation. Now, first here, so after we've created the x and y axis at this new point of origin, all right, then we're going to have to find new coordinates of the object, and then we're going to apply the rule that we had just discussed here, or that we discussed in part 1. So it's going to be imperative that you guys that are watching this video right now are very much aware of the changes that occur under a 90 degrees rotation, 180 degrees rotation, and 270 degrees rotation. Ensure that you know the changes at this point, because I'm just going to be diving right in. Now here's an example. The line Vx has coordinates v 2, 6, x minus 5, 1, undergoes a 90 degrees anticlockwise rotation about the point minus 1, 1. It also undergoes 180 degrees about the point minus 2, 3, and then of course it undergoes, say here, 270 degrees anticlockwise about the point 1, 4. So now I have one line being rotated in 3 different angles from 3 different points. So I'm going to be using this one graph here to demonstrate all of this. So first, let us draw our line Vx. Now V is 2, 6. So let's go on our graph here, and we're going to plot 2, 6 and negative 5, 1. Let's get to that. So we're going to plot 2, 6 and negative 5, 1. Let's use yellow for now. So 2, 6, that is 2 to my right, 1, 2, 3, 4, 5, 6, and 5, negative 1. That's going to be 1, 2, 3, 4, 5, negative 1. So that's going to be my point V, and this is going to be my point X. So that's Vx. Let's make sure that we have everything right. 2, 6 and negative, oh, actually it's negative 5, 1. So it's not 5, negative 1, it's negative 5, 1. So that's 1, 2, 3, 4, 5, and then we're going to go up 1. So this is what we're looking at here, and this is our point X. My apologies there, guys. So then we're going to go ahead then and draw our line, say here, boom, like that. So that's the line that we're going to rotate. Now, as I said, we have changed the point of rotation. It is now at minus 1, 1. So that's minus 1 up 1 right here. This is now where the object is being rotated from. We have now translated the center of rotation from our usual origin here to now this new position right here. Now, how do we adjust for this new point? As the instruction suggests, we're going to create new lines. So we're going to create an x and y axis around this point here. So I'm going to go ahead then, and I'm going to use my pink line here as my point, as my axis. So here I'm going to go ahead and draw a y-axis through here. Okay, then I'm going to draw an x-axis through this point here, and this now point is now acting as my origin. Now, because I've changed my origin, my points on my object, which is my line here, is going to change. So it's no longer going to be, say here, 2, 6 and negative 5, 1. Let us start determining what are the new coordinates of x and v. So from this new point of origin here, this new point here, x is now 1, 2, 3, negative 4, 0. So this here is now negative 4, 0. And v is now, counting this from the origin, this is our new origin, 1, 2, 3, 1, 2, 3, 4, 5. So it is 3 across and 5 up. So our new point here is 3, 5. And so therefore then, we have new coordinates because we have a new center of rotation. Now, as we had suggested here, number one, when the center of rotation is not the origin, then we must create new x and y axis with this point acting as the origin. Check. We must then find the new coordinates of the object using the new origin. Hence, then we're going to apply the rule that we know that changes. Now, we know that this particular line here is going through a 90 degrees anti-clockwise. So based on what we know about anti-clockwise rotation, we know that if we have a random point, say here xy, and it's been sent through a 90 degrees rotation, then what you're going to find here is that it's going to flip, and then of course the y is going to change. So basically then negative 40 is going to flip. Let me just write this down here. So we're going to have negative 40 is then going to flip and become 0, negative 4. Remember that when the 0 goes up, it's going to change, but 0 is neutral, so we don't have negative 0, but the minus 4 comes down and remains the same. This is our new point of, say here, rotation. So that's going to be my new x, that's going to be my x prime. So, okay, so let's just write this over here. And then now we have 3, 5 up here. Okay, that's going to go through the same process, 3, 5, and then it's going to flip over. So this is going to become minus 5, and then we're going to go up 3 here. That's going to be my v prime. All right, and so we're going to go ahead then and plot this object point, this new image point here, and that's therefore going to give us our new line here. So let me just erase this information here. This was in fact what did we say this was? This was in fact minus 40. Okay, all right, so our new position then is going to be, say here, 0, minus 4. So we're going to go ahead then and plot 0, minus 4. We're going to plot it from our origin here. This is the origin that we're moving it from. So 0 means right here we're not going to move, then we're going to go up we're going to go down 1, 2, 3, 4. That's going to be our new position here. So 0 here, 1, 2, 3, 4, right here. Okay, and so therefore then minus 5 up 3, that's going to be 1, 2, 3, 4, 5, negative 5, 1, 2, 3 here. And so therefore then this is our, I believe this is our x prime, and this is our v prime here. And then we're going to connect this to this, and that's going to be our new line of rotation. It's a tricky little question, guys, but once you put some practice in, you're gonna get the hang of it. All right, so we have 2 more questions. I'm going to clear the screen here, and I'm going to try to make it a little bit more seamless for you. All right, so here we go. Let's just clear the screen. All right, so what we're going to have next then, I'm going to change my color then to, say here, green. All right, or let's say here pink. Yeah, let's do green. All right, beautiful. So now wait a little bit, so let's see if we can get it right, guys. Now we have the same point, say here v is again 2, 6, same point. So that's 1, 2, 1, 2, 3, 4, 5, 6. That's our point v. And then our point x is negative 5, 1. So that's to the left, 1, 2, 3, 4, 5, up 1. That's my point x. So we already have that point here. See right here. That's my line. All right, let me just draw that a little bit straighter. Good. And that's the line that I'm going to rotate just like I did before, except now that I'm going to be rotating it 180 degrees, but I'm going to be rotating it from the position, say here, minus 2, 3. So we're going to locate that new position here, minus 2, 1, 2, up 3, 1, 2, 3. So we're going to be rotating it at a point that is actually on the line. So here we're going to go ahead then and place, say here, this color. So -2, 1, 2, up 3, 1, 2, 3. We're going to be rotating it from this position right here. That's going to be my new center of rotation. I'm then going to go ahead, then I'm going to draw 2 new axes. So I'm going to go ahead then and use my pink line once again. And I'm going to rotate it here, say, okay. So I'm going to go ahead and draw a line coming down like that. That represents my new y-axis. And then it's going to also represent here my new x-axis here. This position here that I've labeled here in blue represents my new origin. Now, of course, x and y cannot have the same coordinate values. They cannot have the same coordinate values. Of course, first they were, say here, 2, 6 and -5, 1. I've created a new axis. So now it's going to change. We need to determine those new coordinates in comparison to this new origin that we've created here. So x here is now simply going to become 1, 2, 3. That's -3 and down 2. So my x now is -3 down 2. That's my new x value. And then my new v value then is going to be 1, 2, 3, 4 to my right, 1, 2, 3 up. So that's 4 to my right and 3 up. That's my new coordinate values of v and x in comparison to the new point of origin or the center of rotation. And so therefore then, of course, we're going through 180 degrees. So we know that xy goes through 180 degrees will become -x, -y. So therefore then all the points then, say here, v, which is 4, 3, is going to become -4, -3. And then of course we're going to find that -3, -2 is going to become 3, 2. So then if we plot -4, -3, so that's -4, that is going to be 1, 2, 3, 4, and -3, 1, 2, 3, we're going to be right here. Let's just move this information here. Oops. We're going to move this information here. All right. So that was in fact, I think we said that this was 3, 2, was it? Let's see here. X was 1, 2, 3, down 2. Okay, so this was in fact 3, -2. That was the point. So then after doing, I think I made a mistake, guys. It was in fact, okay, so it was right. Sorry, my bad. I think I wrote it down incorrectly. It was in fact -3, -2, because here x is, we go into the left, 1, 2, 3, and went down 2. So yeah, we have it right. -3, -2. And so therefore then we're going to go, we're going to land at this new position here, because after flipping the point, sorry, after changing the signs, as opposed to being -3, -2, it's now 3, 2. So we get 1, 2, 3 and up 2. That is at this position here. Okay, 3, 2. So that's going to be our new, say here, x prime. All right, and then so forth. Then we're gonna have, say here, 4, 3 is going to become -4, -3. So that's 1, 2, 3, 4, 1, 2, 3. We're gonna be at this position here, there. And so therefore then from this point here, we're gonna end up with this sort of line here, like that. Right, so it has a, so the reason why it's the same line is because the center of rotation is actually on the actual line. So it's like almost like you turn the line the other way, pretty much. So you turned, notice that V prime is now down here. V was actually up here and it's now down here because it went through 180 degrees turn. And then X was down here, it now lands up here, that is X prime here. So tricky little bit here, guys, tricky little bit, but I know you guys are getting it, right? So we're gonna try it one more time here with a new example. Same point, same here, V and X. I would have rather though that I use different points for this rotation, but nevertheless, guys, I just hope that you guys are getting it. All right, so take a screenshot of that. Let's go ahead then and continue plotting our points. All right, let's try this one more time, guys. Let's see if we can get it. And this is somewhat kind of new to me because, as I said, I've learned this. I've learned many ways of rotating an object, but I've never found this unique way. And I've been making some discoveries, so I've definitely wanted to share them with you. All right, let's go ahead and plot back our original points. Our original points were 2, 6. So let's go ahead and say 1, 2, 1, 2, 3, 4, 5, 6. That's right here. And that's going to be our V. And then, of course, now we have negative 5, 1. So that's going to be 1, 2, 3, 4, 5. I'm going to go up 1. So that's going to be our X. All right. And then, of course, now we're going to be rotating it again now through 270 degrees anti-clockwise, but we're going to be rotating it from the point 1, 4. So that's going to be 1, 1, 1, 2, 3, 4. So we're going to be rotating it from, let me get a different color here, same ink, same pink. So that's 1, 1, 2, 3, 4. Okay, 1, 1, 2, 3, 4 right here. So we're going to be rotating it 270 degrees. So this is going to be our new center of rotation. All right. Now we're going to have to create axes around this line. So here we're going to go up like this. And we're going to go down. That creates our new X and Y axis. And then of course, we're going to go ahead and go across like that. So. And then go across like that. So that's our new axis. That's where we're counting from. Let's give it a different color here. Let's give it, say here, blue. Right, so this is our new point of rotation. Okay, so we're going to be rotating the line here. Let me just draw my line. I forgot to draw my line, guys. Boom, like that. We're going to be rotating this white line here through 270 degrees from the blue position here. All right, now bear in mind that if we change our point of origin, then obviously the points for V and X are going to also change. So the V that we had as 2, 6 is now 1, 2. So this is now 1, 2. Let's just write the original point first. So first, upon plotting it, it was 2, 6. But then because of the new origin, it becomes, say here, from blue, 1 and up 2. So it now becomes 1, 2. And then X now, that we said was -5, up 1. That was our original. So it was -5, up 1. Oops. -5, up 1. Because of the new axis, it's going to become, let's count, 1, 2, 3, 4, 5, 6, 6. So that's -6, 1, 2, 3. So it becomes, say here, -6, 3. Let's just write it back here. So it was -5, 1. So it's now, according to the new change, -6, -3. That's the new position then. All right. So once we have that new position, then we're going to have to go through the whole process of changing the points. All right. So we know that under a 270 degrees anti-clockwise rotation, anti-clockwise rotation, you're going to find that any random point will pretty much have a interchange in the signs and the X is going to change. So that's what we know for sure. So then therefore then all the new points then, that is now 1, 2, and also the new point here, -6, 3, -6, -3. Let's double check on that point. Let me see here. 1, 2, 3, 4, 5, 6. 1, 2, 3. Okay, we're good. We're good. Just want to make certain, guys. Okay. Right, beautiful. So that's going to go through the change that we have on the left here. It's going to flip and change the signs of the X. So 1, 2 is going to flip, and then 2 is going to remain positive, but 1 is going to go down and change to negative. And then of course -3 is going to go up, and -6 is going to go down and change here. So according to the rotation of 270 degrees, say here about the point 1, 4 will produce the new points 2, -1 and -3, 6. Let's have a look at what this looks like after the rotation. So then I'm going to put the rotation here in blue. So 2, -1, so that's going to be, say here, 1, okay, from this point here, 1, 2, -1 right here. And then of course we're going to have -3, 6. That's going to be from here, 1, 2, 3, 1, 2, 3, 4, 5, 6, all the way up top here. So let's go again. 1, 2, 3, 1, 2, 3, 4, 5, 6, all the way up here. So therefore then what we have then is, say here, boom, like that. Oops, pardon me guys. Okay, there we got it back. So we're gonna have, say here, this position like that. Oops, still not straight. Like that. Beautiful. So that white line went under a 270 degrees rotation about the point, say here, 1, 4. All right, that is how it is done, guys. So a tricky little bit there for you. This is definitely a more in-depth, intense, in advance. It's not really advanced, it's just a different way of approaching finding the center of rotation. All right, and that's pretty much what we are referring to now. As you can see here on screen, guys, coming up is the topic of enlargement, one of my favorite topics to teach. So you definitely want to stay tuned for that. Let us do a quick recap here. In this video, we were able to cover how to actually use the matrix equation mapping to find the center of rotation. And we also looked at a new way of finding, say here, the center of rotation using translation. All right, now of course I said I don't have the digital tools to show you the construction, but I'm gonna try to perhaps say record or screen record this, me doing it like physically with my hand, and then in one of my other uploads I'm going to like attach it to the video. So hopefully you guys can get a hang of that. But on my digital tools that I have here, I'm not able to really show you effectively how to actually get the center of rotation using construction, but we're gonna get to that later in future tutorials. All right, so thank you so much guys for staying tuned. I do hope that you find some sort of value from this. Right, it's very new. It's not really like a huge thing, especially for CSEC students, but it's good that you at least have an idea of how to make this adjustment for the center of rotation. All right, so until then, take care. Next time I'll see you in another tutorial video. Please like, share and subscribe. Leave some positive questions and comments down below. Until then, take care. Bye bye.